arithmetic. Alright, 2 maths. That's similar to your homework. Just go over 2 maths like this. Okay? Open it. This is just open it again like this. Again, I have 1, 2, 3, 4, 4 complex number open loop, and in matter of fact they have only 2 pair because they are complex conjugate, so only 2 pair. And then the cross defect again I want to have a ending for this 4 different 4 eigenvalues. I just add minus 0.5. Another one I add the same minus 0.5 plus minus. And this minus 0.5 is arbitrary chosen. I didn't have any. Just for example, there's no reason there's no reason to choose minus 0.5. You can choose any value. I give you different value already in your homework. But that's multiple input. Right, let me go back. Right, this is multiple input. I have 2 input. So PC has 2 columns. See, my PC has 2 columns. 2 input. Now, 3 input I got more freedom now. Now, cross-field eigenvalue, my desired one. This is my desired cross-field eigenvectors. And this desired one, as a matter of fact, that's the open loop eigenvectors. Alright? And my desire, this, the first one, okay, that's my desire one, assume. That's the desire one, this one, will be my desire eigenvector for minus 0.5 plus 1.618. And this is the second one, the minus 0.5 plus 0.618i. And I didn't have number 2 here, I didn't have number 4 here, because number 2 has to be a conjugate of this one. Number 4 has to be conjugate of this one. Okay? So, that's for number 1. Or that's the open loop vector of number 1. In matter of fact, this vector is the open loop vector of number 1 multidimensionally. I use open loop eigenvectors. I move the eigenvalue, but I don't want to move eigenvectors. They want to mean. So we know that. If we move one eigenvalue, we don't move eigenvectors, hopefully. Our gain will be small. Because we move one eigenvalue, we don't move eigenvectors. Right? And we say desire, look at this. Desire gain. I say I want to be 0, 0, 0, 0. And we know that we cannot get that. But we will be as close as possible as the small value that's the 0. So that's 0, 0, 0, 0. So I desire, now I define a desire cross eigenvectors and matrix. I define my desire cross loop again matrix and this 2 input because I have 2 input. Now my gain within the matrix will be a matrix. Alright, look at this. Now, I have 4 by 6. And this last 2 column, that's for my BC. Alright, and this 4 by 6. So I expect to have more space V01, which is 2 vectors. That's my V01. I have 2 vectors. It's not 1 vector, it's 2 vectors. Now what I'm going to do now for 2 vectors? For 2 vectors. Okay, now I want to have my desire. This is so my desire C1 I put in my desire D1. That's not including the not including this, not including this my desire the vectors, eigenvectors, and this is all 0, right? Right? This is 0. That is my desired decaying negative matrix. If I do that, I can solve my C1. So my C1 is this. So now I get my C1. This is the eigenvector for number 1, that V01 times C1, that's the one I really get. Alright? This is the one I really get. This is the one I really get. But this is not the same thing as my desired one. In other words, that I just got V1 free head 1 minus my desired free bar desire 1 and free head desire 1 and norm is minimum. I just get that. In other words, I cannot get my desire, really desire the vectors. I get only the minimum I get. That's for number 1. For number 3, the same thing, I have to solve this. Putting number 3 here. What's my number 3? That's here. That's my number 3. That's my number 3. Okay. And this is my number 3. Okay. That's my number 3. And for my sigma, cap sigma 3. Okay. The new space vectors. V03, see I skip number 2. Because number 2 is the conjugate of number 1. So I don't have to bother with number 2. For 4 eigenvalues, I need to do only 2 eigenvalues. Because another 2 will be conjugated. So I have a 2-bit null space. Right? And again, that's my head. That's my head. And I C3, I solve this way, put my desire one here, that's my desire one. And I will give you desire vectors. I don't know what 2 pages of ago, and that's for my number 3. So again, this vector I solve is as close as possible to this. These 2 vectors is as close as possible in a discourse sense. Alright? You understand that? I should put my desire on the left hand side here so you can compare. Because I know that desire last two values have to be 0, 0, right? But they are not. It cannot be 0, 0. 0, 0, that's what you wish. So, one way that I can do is, for FC is equal to head, and this head, and this head, alright? And that means FC equal to like that. See? That's very complicated. That's the value. And I do have to make inverse of that 4x4 matrix. Hopefully that 4x4 matrix is a real condition. So my FC, I do it just like that, simple. So that's all okay. That's my game. And this game will give you desired eigenvalues. So believe me or not. That's supposed to give you the desired eigenvalues. Alright. I run through quickly, for example, I assume that you understand the theory. As soon as you understand the theory, those examples just simply apply those 2 equations to the example, that's all you need to do. And then you get a real, you gain matches like this. Do you have any questions? How about on the other side? Do you have any questions? I can see you. Raise your hand if you have a question. You can speak it out. The theory looks quite difficult to understand. But again, in practice, this is a very useful technique. We also apply this to our real test structure in our lab. And of course, that to give the desired eigenvalue, you have to think. You have considered a lot of factors to do like that. Other than that, it's, in terms of method itself, it's simple. If you have a problem to do this, if you know the desired eigenvalue,